When we have parametric equations, we can find dy dx by doing dy dt divided by dx dt. And we can see that this works using the rules for fractions. So if we had dy dt divided by dx dt, dy dt, that's the same as dy dt times dt dx. And then the dt's cancel out, and it leaves us dy dx. So dy dt divided by dx dt gives dy dx. This question says find the gradient at the point where t equals pi over 4 on the curve given parametrically by x equals 3 sine t and y equals 2 cos t. So let's work out dx dt and dy dt. So dx dt, x equals 3 sine t. When we differentiate sine, we get cos. So dx dt is 3 cos t. Y equals 2 cos t. So dy dt. Cos differentiates to give negative sign. So it's negative 2 sine t. So dy dx is dy dt, negative 2 sine t, divided by dx dt, 3 cos t. We want the gradient when t is pi over 4. So let's substitute pi over 4 in. If we wanted to, we could change sine over cos into a tan, which might make it easier. So just type it into the calculator. So it's negative 2/3 tan pi over 4, which is negative 2/3. One for you to try. See if you can give it a go. So again, find the gradient, this time at the point when t equals 2 on the curve given parametrically. So we're going to say that dy dx is dy dt divided by dx dt. So we want dx dt, which is 2t plus 5, and dy dt, which is 5. So dy dx is 5 over 2t plus 5, and when t is 2, dy dx is 5 over 2 2's plus 5, 5/9. Another question. A curve has parametric equations. X equals t squared plus 2t. Y equals t squared minus 3t minus 4. Find the equation, the tangent to the curve, when t equals 2. So we're going to say that dy dx is dy dt divided by dx dt again. We're also going to need to know a coordinate on this, on the tangent. So when t is 2, we're going to find the x and y coordinates by substituting them in. So let's do that first. So when t is 2, x is 2 squared plus 2 2's. So x is 8. Y is 2 squared, 4, minus 6 minus 4. So 4 minus 10, y is negative 6. So we've got a set of coordinates. We're also going to find the gradient. So dy dt is 2t minus 3. Dx dt is 2t plus 2. So dy dx is 2t minus 3 over 2t plus 2. And when t is 2, our gradient is 2 2's take away 3, which is 1, over 2 2's plus 2, 6. So now we just substitute in y minus y1 is m times x minus x1. So y plus 6 is a 6th times x minus 8. And we could rearrange that to give it in another form, but I will leave it as it is. One for you to try. See if you can give it a go. A curve has parametric equations. X equals 2t cubed, y equals t squared minus 5. Find the equation of the tangent to the curve when t is 1. So when t is 1, x is 2 times 1 cubed, so x is 2. Y is 1 squared, take away 5, so negative 4. And we want dy dt, which is 2t. The x dt is 6t squared. So dy dx is 2t divided by 6t squared. And when t is 1, the gradient is 2/6 or 1/3. So substitute into y minus y1. So y plus 4 equals m times x minus x1. So y plus 4 equals 1/3 times x minus 2. And again, we could rearrange that to put it in a different form, but we don't have to. I'll leave it as it is.